In this video, we continue to explore the capabilities of the correlation matrix. In the previous video, we developed a correlation matrix between volume and unit price. But imagine that we reasoned that unit cost would also depend on the volume. So we would like to add unit cost to this matrix. I've highlighted the matrix here. I go back up to define the correlation matrix, and it reopens this window. When I click on the show scatter plots, it gives me back the numerical view. Now I want to add an input. I'm asked to identify the input, and it is the value in B6. I say OK, and now you see we have an additional row and column. So I'm now looking at volume and unit cost. This time, let's assume that that also has a 0.8 correlation, but it's positive. The more you produce, the greater the unit cost. So now you see a 1, and we have 1s along the diagonal, and a minus 0.8 and a plus 0.8. I go now to click on the OK, and I get an error message. This matrix is not self-consistent. At risk can generate the closest self-consistent matrix. If I click yes, that writes the corrected matrix to Excel. No writes the inconsistent matrix to Excel. So here's what's going on. Let's move this. This is saying if you have a high correlation between unit price and volume, and a high correlation between unit cost and volume, then unit price and unit cost must be correlated as well. But you'll notice unit cost and unit price, this value right here, is 0. So that says there's no correlation. So let's see what happens if I click on yes. That's going to correct the matrix. What this has done is it's changed my value from minus 0.8 and plus 0.8 to minus 0.8 and plus 0.7. So it has reduced this correlation. These two correlations now are compatible with no correlation between the two values. I'm going to select my matrix again, go to define correlations, and I'm going to change this back to 0.8. Now this time I would like this to remain minus 0.8 and this to remain 0.8. But I would like to know what this correlation is. So I'm going to put my cursor in this cell, and I'm going to go down to this check matrix consistency box. I'm going to enter an adjustment weight, and I want a weight of 100. That means leave this as it is. These cells have turned red now to indicate that they do have an adjustment weight of 100. I'm going to come down here, once again go to my check matrix consistency box, enter an adjustment weight again of 100, and this time I'm going to say OK, and I'm going to select yes to write a corrected matrix. So the 100% weight says leave this value minus 0.8 as close to minus 0.8 as possible, and this value 0.8 as close to 0.8 as possible, and adjust this accordingly. So this is telling us, you'll notice this has stayed at minus 0.799 and plus 0.799. So these have changed relatively little, but we now have a correlation between unit cost and unit price of minus 0.27. So we have a prompt over here now. It says, you have entered adjustment weights. Would you like to save these in an adjustment weight matrix in Excel? And we're going to say yes. And it asks where we want to put that matrix. I'll say put it here. And now we have two matrices. You can see here that this has changed so little that it still rounds to a minus 0.8. The 0.8 has changed marginally, and now we have a correlation between cost and price. We've eliminated the risk simulation table. So let's now run one last simulation here of 5,000 iterations. Here we have a 44.3% chance that the project will yield a negative profit. But in this particular model run, we have accounted for correlations among the three variables. And that's basically how you would use a correlation matrix.